Good morning. This is Al Hoheb. I'm the Senior Project Leader at the Aerospace Corporation, who's serving as the overall System Engineering Forum Chair. With me this morning is also Alex Chang. He's my Associate Chair and monitoring chat. And we're bringing this to you via our CorpCom team, which is running the production behind the scenes. And it's my pleasure to also introduce Dr. James Martin in just a minute. So I'll provide a couple of housekeeping remarks. Next slide, please. The System Engineering Forum is a set of virtual events this year, and it's hosted by our Corporate Chief Engineer's Office. And the focus is on model-based system engineering across the space enterprise. So we're looking at how model-based systems engineering contributes to mission success while fulfilling the digital engineering mission. And what that means is we want to make sure that when we apply model-based systems engineering, it certainly takes advantage of all the digital engineering constructs, but really it benefits the overall approach to the space enterprise. Now, these events that we're providing have springboarded off of our face-to-face events in the past. So in 2016 through 2019, we ran face-to-face meetings, and because of COVID in 2020, we had to cancel our 3-day event. So we've gone virtual, like most of the other parts of the community, to provide you these sequence of talks. And these talks are applicable to a very wide audience. The materials for these talks are for public release. So if you go to the System Engineering Forum registration page, there's an archive button, and you can click on the button and download PDFs of both the charts and also a reference paper. We're recording this presentation as well, and that's going to appear on our Aerospace YouTube video channel. Once that video has been posted to YouTube, we'll provide you an email and a URL to access that. So we're proud of being able to provide this to our space community. Next slide, please. All events begin at 8 o'clock Pacific time, and registration closes 2 days prior to each event. So you've already gone through our registration system, but have no fear. If you miss a registration or you have a colleague that misses a registration, you can still download the materials and you still can access the videos after the fact. So this is our lineup for the rest of the fiscal year. We're going to kick off today with the Enterprise Architecture using UAF talk by Dr. James Martin. Then we're going to talk about mission assurance levels next month, the Model Portfolio Management Guide in May. In-depth is going to be in June, and what that is that's an overview of a digital engineering ecosystem model that can be used as a template for other digital engineering ecosystems. And then we're going way out of the box in designing for principles, in which we're going to provide alternative approaches to requirements-based acquisition. And then we're going to capstone the fiscal year with model-based mission assurance and flight worthiness. That's where we use model-based activities to do mission assurance and flight worthiness. And that, again, that's very groundbreaking. So we're very excited about our lineup this year. With this, you're also going to be getting a follow-up email to provide some feedback to us. And if you have ideas on what you'd like to see in the future, maybe next fiscal year, that would be a great opportunity to let us know. Next slide, please. So this event is recorded. And as I mentioned, the recording will be available on YouTube. So a couple of ideas here. We'd like you to mute your mics and keep your video camera off. That'll help us conserve bandwidth, and that'll also help us make sure that this presentation moves along smoothly. If you have any Zoom issues, you can go back to our System Engineering Forum page, and there are troubleshooting tips there. And also we should have a troubleshooting tips document that you can load if you're having problems navigating through this Zoom interface. So for the best experience, click on the view button on the top and go into speaker view. We're going to take questions along the way via the chat box. So Alex Chang is going to be monitoring our chat, and he's going to provide that to our speaker. Our speaker also will pause at different points within the presentation to allow the Q&A to continue. And then we're going to give you a little bit of a bonus today. While our talk is scheduled for 2 hours, 8 to 10 Pacific time, Dr. Martin said he's available for another 30 minutes to take Q&A questions. Then that will be more free form. So at the tail end of the presentation, I'll conclude the formal meeting. We'll proceed with a 30-minute Q&A session, and we'll open up the mics for voice if you'd like to use voice. Next chart, please. Okay, so it's my pleasure to introduce Dr. James Martin. His specialty is enterprise systems engineering with a focus on enterprise architecture, which includes the processes, methods, and tools for how you do architecting. He's a member of the Object Management Group Revision Task Force for the Unified Architecture Framework and is the primary author of the UAF Guide. Dr. Martin is an NCOSE Fellow, and he's earned a PhD in Enterprise Architecture and is a Principal Engineer at the Aerospace Corporation. So with that, I'm going to turn it over to Dr. Martin.
Thank you, Al. Thank you for inviting me to attend this session. I should be sharing my screen now, so please let me know if any problem seeing that. I will. I've been working with the Unified Architecture Framework for about 3 years now. I'm the Aerospace Corporation representative on the Revision Task Force, so I'm helping advance the state of the art. We're now working on version 1.2. So one of the main topics of the second half of this session will be going over the UAF guide. It's basically a user's guide for how to use the framework, because the framework was originally mainly intended for modelers, tool developers, and so on. But a lot of architects and managers and directors have asked us, well, I don't quite understand UAF, so we're writing this user's guide for those who, it's also for modelers, but also for the people using the models and figuring out, what kind of model they can ask for. So here are the topics we're going to cover. I'm going to spend most of my time on the user framework itself, the architecture framework itself, and the user guide. But I want to spend the first 20 minutes or so covering, giving some background on some important concepts that you need to understand that will help you understand, why the framework is built the way it is and how you might use it. So UAF is specifically intended for modeling an enterprise, unlike other modeling languages like SysML and UML for systems and software. So it's built upon SysML, so you can always use the knowledge you have of how to model using SysML, but it also gives you actually captured key concepts that are used in the enterprise, and I'll go through all the key concepts that are available in the framework. So the main reason you do enterprise architecture is for transformation of the enterprise, and what's the nature of that transformation. It's a little bit different than developing a new system that's replacing an old system. Usually you have some sort of transition period and you flash cut, but enterprise transformation is different in the sense that the enterprise is changing every week, every day, every hour. So it's continually changing, but you want to go through some sort of transformation steps. And one way you do that is through the portfolio management process. So the architecture models you build can help inform the portfolio managers. It's also important to understand that there's different tiers of enterprises. Think of it as enterprises are contained in other enterprises, which are contained in other enterprises. We call those architecture tiers. So the architecture framework is a way to describe standard views for describing an architecture. I want to tell you how this UAF got here from an evolution of several steps going back about 20 years. The frameworks are incorporating modeling languages, and they're using elements in the modeling landscape. So when we learn system engineering, we learn the input-output method, sometimes called the IPO, input process output. We treat the system as a black box. We look at all the inputs and figure out what does the system need to do to be able to transform those inputs into those outputs. Enterprise is different in the sense that you don't normally draw the black box of enterprise and figure out all the inputs, because there could be hundreds or thousands of inputs, and there could be hundreds or thousands of outputs. So when you do enterprise architecting, you tend to focus on different things. Instead of inputs, you focus on drivers. What's driving the enterprise to do what it's doing? If it's a scientific enterprise, there may be some key science questions. If it's a business enterprise, it may be the drive to make a profit, return higher share price to the stockholders. The outcomes is not the same as outputs. Outcomes is the results you're trying to achieve by the enterprise doing its thing. Okay, this is not to say that systems don't have drivers, systems don't have outcomes, but at the enterprise level, you mainly focus on drivers and outcomes. So one of the key differences is usually you decide, the system engineer decide what the system is going to do. In enterprise, it often decides on its own what it's going to do, how it's going to do it, what goals it's trying to achieve. So enterprise is more like a living system because it has some attributes of living people. In fact, the enterprise is made up of people, which is why it acts that way. So to make an analogy, system architecture is like the blueprints for a building. The designer of the building comes up with drawings of that building, and they give the drawings to a builder, and the builder can go build it for the people who are going to live there. So it's very predictable. Anybody can look at the drawings and figure out what the house is going to look like when they move in. Enterprise architecture is more like urban planning, where there may not be a single blueprint, there may not even be a set of drawings, there may be these, depictions, maybe they're sketches like this, but an urban area could be tens or hundreds of thousands of square kilometers, and it could include millions and millions of people. It could include tens of thousands of businesses. So the urban architecture is laying out where you can build housing, where you can have industrial zones, where you have parks, where the transportation networks go, how will the traffic flow between these different regions of the urban area. So urban planning is a good analogy for how the enterprise architects think of their enterprise, because it's a living thing. So the enterprise is taking these drivers, and whatever they are, here's some example drivers. There could be the demand for the enterprise services or products. There could be competition with other enterprises of similar nature, laws and regulations that tell us what we can and cannot do. The various assets like people, technology, investments that the enterprise uses to do its thing. So it's using work processes within the enterprise to change the enterprise state to achieve the desired outcome. So in terms of enterprise transformation, how do you get, given all those drivers, how do you change the enterprise so it can better achieve those outcomes in the most efficient and effective manner? So the enterprise does this by looking at their portfolio. They have a current portfolio of systems, projects, programs, buildings, properties, intellectual property, patents, and so on. And they would like to envision some future portfolio where all the assets in their portfolio will change. So there's many ways you can change those assets. And given those drivers and the desired outcomes, you look at various alternative future portfolios and figure out what the best one that takes account of all the drivers and achieves those outcomes in the you might say faster, better, and cheaper. So an enterprise is not just one thing. The enterprise is usually part of a bigger enterprise. You could even think of our project or program that we work on as an enterprise. But given the enterprise is really more like a large complex venture, typically programs are more like systems and projects are more like systems because the enterprise is a living being and the project is more predictable like a system. So I call tier 6 is where the traditional system engineering happens within a project. Now there may be a system of systems that's dealing at the program level, but tier 4 above that is a mission area or capability area. And you can see some example there. The mission to the moon is an example of a mission area. Launch is a capability that enables the lunar mission to come about. Missile defense is a mission area for providing national security to a country. Tier 3 above that, command service agency, various, there could be military commands, military services, but it could be civil agencies. It doesn't have to be military. This terminology happens to be the terminology used for tier 3 in the defense world, but you can take the same ideas of these tiers, and for your domain, whatever it is, whether it's a public domain, private commercial domain, whatever, you can come up with, there's always going to be multiple tiers. And the top tier is the community, and in the most extreme case, the entire global community. So these are the tiers. And UAF is specifically designed for modeling enterprises, tiers 1 through 4, sometimes 5. Now, you do have systems at tier 5 and 6. That doesn't mean you cannot use UAF to model the systems there, but usually you would eventually go into the details of the system using the SysML modeling language. So when you model systems in UAF at tier 5 and 6, you're usually taking a higher level look at the systems and looking at the system from an enterprise perspective. So yes, you can model the systems, but UAF is not designed for modeling a lot of the details of those systems, because that's what lower level modeling languages are for. So here's an example of walking through tiers. So take the top level domain, space exploration. There's one agency administration in the U.S. government called NASA, and they're responsible for that space exploration domain. And one of the directorates within NASA is human exploration. And within human exploration directorate, they're responsible for the lunar mission, but they're also responsible for developing launch capabilities. Within the lunar mission, you have the Artemis program, which is the program that's responsible for building the equipment for performing the lunar mission. And the International Space Station is another program. And so that program, those two programs will work together to jointly work on the lunar mission. So even though the International Space Station is separate, so this is what you see is even at each tier, you'll have tier level enterprises, then you often have joint activities, joint responsibilities. Down within the Artemis program, you have the Space Launch System, SLS, you have the Orion crew launch vehicle, the crew vehicle, the lunar lander, and the lunar habitat so people can live on the moon. So here's an example of various enterprises all the way down to the programs and projects that maps into these tiers. So what do we mean by an architecture framework? Some of you, probably most of you, are familiar with the DoD architecture framework, because those who work in the defense community, that's been a standard for about 20 years. So there is an international standard on architecture frameworks called 42010. And this is the definition they provide. It's the conventions, principles, and practices for describing an architecture within a specific domain. The DoD architecture framework, which for the defense domain, obviously. So others, things like the TOGAF, the Open Group Architecture Framework, is specifically designed for the information technology domain. And the Federal Enterprise Architecture Framework, the FEAF, is beyond IT to model government agencies across the board. So the Unified Architecture Framework that published by the Object Management Group is one of those examples of intended to be a cross domain. It started out of defense aerospace, but it's already starting to be used in other domains outside of the original defense and aerospace origins of it. So if I group the various frameworks that are out there, there's a number that are IT focused. The Zachman framework was, some people consider that to be the original framework from back in the 70s. John Zachman worked for IBM, and it was originally meant to be an information systems framework for helping people incorporate mainframe computers into their business operations. And the other frameworks in the IT column were all based on the Zachman framework and expanded it into different areas. So you can see the acquisition focused, because in the defense community, they need to acquire large complex systems. So you have these various defense frameworks, plus the NATO framework, which cuts across several countries. So these four frameworks you see were not compatible with each other. So they approached the Object Management Group and said, okay, you're an international standards organization. Can you help to unify a single framework that we can use to generate all the views that we need within our framework. So if you use UAF to generate architecture views, you automatically get DoDAF views, Canadian National Defence views, and the UK MODAF views. In other words, it's a unification of sorts. It merges and integrates the various frameworks and unifies the underlying meta model. So one of the original frameworks in the defense world was the C4ISR. C4 stands for Command, Control, Communications, and Computing. ISR is Intelligence, Surveillance, and Reconnaissance. So originally it was just a simple aggregation of the various frameworks that the different services had, like Army, Air Force, and Navy, and some of the government defense agencies. So it's really just not even an integration, just an aggregation in version 1. But version 2 of the C4ISR framework did a much better job of integrating all those so they're more compatible with each other. And then about 5 or 6 years later, they expanded it beyond C4 and ISR to the entire defense community. So that went through another major iteration 6 years later in version 2. And then, so the last time DoDAF was updated was 2009. So that's over 11 years ago now. So UAF came out in 2017. So we're now into the 4th year, and we're working on the 3rd version of that. So you can think of UAF as a 5th generation architecture framework in the defense aerospace world. So you can see the architecture framework here. So here at the top, you see this framework here. So we were just talking about architecture frameworks. So the framework fits within a bigger landscape of various things we use when we're doing modeling. So we all use some sort of modeling language, whether it's SysML or maybe an informal language of just boxes, lines using PowerPoint. When we model, we're always using some kind of language. Our goal is to build some sort of modeling methodology because we want to eventually build models and then build views, and those views make up the architecture description. So this I call the modeling landscape. So we're going to focus on the Unified Architecture Framework and a modeling workflow. So during the next hour and a half, I'm going to focus on those 2 things for the Unified Architecture Framework. I'm not going to get into modeling methodology because that becomes very specific to your organization. But every organization will have one, whether they document their methodology or not. But the modeling methodology is just really a combination of the workflow, the modeling profile, and various modeling patterns and templates. So modeling languages. Software has been modeled with the Unified Modeling Language for quite a number of years. And later on, SysML, the systems engineering community realized that UML will only take certain aspects of a system. So they extended UML with a modeling profile to support the system engineering practice. Then later on, people started using SysML to model the enterprise, and they started to realize, well, we need to do another extension with the unified profile for DoDAF and MODAF to show how SysML can be used to generate the 52 DoDAF views. And then later on, that was evolved further to the Unified Architecture Framework profile, which is essentially an enterprise modeling language. So don't be confused by the word profile. That's modeling jargon for a modeling language. So it's based upon SysML. So when you look at many of the UAF diagrams, they look like they're SysML diagrams, and that's because they are. However, there are some views, and you'll see those later, that you cannot even generate with SysML. So take SysML, but build upon it. For example, business process modeling, project timelines, system roadmaps, and various other kinds of views that SysML by itself cannot even generate. So here's the landscape of the 4 main modeling standards that come out of the object management group. SysML, most of you are familiar with, because that's used quite commonly in system engineering. When we hear about model-based system engineering, MBSE, most of us think about SysML, but there's nothing that says you have to use SysML for MBSE. If you're doing a software system, you may just use the UML, but if you're modeling the enterprise, anything above the project or program level, then it's usually more appropriate to use the Unified Architecture Framework, because it's specifically designed for architecture that include things like strategy, operations, services, security, organizations, and standards. The fourth modeling standard is for business process modeling. So unless you're in the business architecture world, most of you probably would not use the BPMN. However, we can model our mission activities using BPMN if we prefer a more sophisticated business process modeling notation. So here's how these 3 UAF things, the OMG standards of SysML, the UAF Profile, and the Unified Architecture Framework fit within the modeling landscape. So as I mentioned before, the last 30 or 40 minutes, I'm going to show you the modeling workflow that we're developing, and that will eventually become a part of the UAF standard. So our plan is to have that out this summer. So I'm going to be giving you a preview of what that's going to be looking like. So we covered some enterprise concepts, explained a little bit about how enterprises are different than systems. And the reason we do enterprise modeling is so we can inform the decision makers who are trying to transform the enterprise in an effective manner. And they're using the portfolio management process, which can be utilize the architecture as a key information source on alternative ways of changing the portfolio. We talked about the nature of frameworks, how they've evolved over time, and how languages are used as the core elements in modeling the architecture. But they're going to be using the languages to build the views that are defined by the framework. So the UAF specification from Object Management Group has 3 different parts. There's the framework grid, which is a 2-dimensional grid with rows and columns. And within that grid is where you have the view specifications for UAF. So that's defining what the views are and what kind of things you can put in the views. The domain metamodel on the right, that's the underlying modeling constructs that you're allowed to use when you're building UAF models. And then the thing in the middle is the profile itself, basically the modeling language for modeling an enterprise, which is a combination of SysML notation with using the domain metamodel constructs. So what are the benefits of using the UAF versus some other framework like DoDAF, or using one of the software architecture frameworks or whatever? Well, one is if you're doing MBSE at the enterprise level, it will better enable you to do model-based enterprise architecture. If you, as I mentioned before, if you generate the UAF views, they automatically give you the DoDAF views. So you don't have to choose between UAF and DoDAF. It's really just a matter of, the DoDAF is already 12 years old. So it's a matter of using the more modern framework of UAF that already incorporates UAF plus some additional views that you cannot even do using DoDAF. It provides the common enterprise ontology, and I'll walk you through the various elements of the ontology so you can see what I'm talking about. These are the basic enterprise concepts that you would normally find within an enterprise architecture. So as part of that ontology, they give you the common modeling vocabulary, just like SysML. It talks about blocks and activities and actions and interfaces and ports. UAF also provides the standard modeling vocabulary for modeling the enterprise. Since it's based upon SysML, it uses the standard SysML notation, so it's much easier for SysML modelers to pick it up. It's aligned with the ISO standard on architecture description. It's also, because it's an OMG standard, it's well integrated with all the other OMG standards. And because it's designed specifically for enterprise modeling, it's really good for modeling the life cycle of various entities within the enterprise. It also provides several new views that did not exist in DoDAF, such as security views, personnel, requirements, analysis, and simulation. So now we're going to talk about, this is just showing the same three things on the left are things I told you about. The profile, think of that as a language. The framework is just a way to organize the views. But there's two other components. They're the non-standard part, they're not normative. There's the traceability between UAF and back to the four originating frameworks. And there's also an example model for search and rescue. So think of that as a mission area, search and rescue mission area. So that's a full example using all the 71 views within the framework. So if you don't understand how to read a meta model or the profile, you can just open up the search and rescue sample model to be able to understand what a UAF model might look like. So this is the 9-step workflow that we're developing. So this is going to be part of the user guide on how to generate those 71 views, because when you have 71 views, it's not always clear how they relate to each other, and is there a particular logical sequence of building these things. So this is a standardized workflow that can be built into the modeling tools. So you can start with this and tailor it down to just the pieces you need, but at least you still have the logical connection between all the views. Underneath you have the meta model, has 230 concepts in it, but that's way too many things for most modelers. A higher level view of the basic building blocks within UAF. So think of this as 4 levels. At the top level, you have the strategic elements of the enterprise phases, milestones, the capability that the enterprise is delivering. And the second level down is the operational activities being performed by the enterprise. And those activities are what will generate, or will give you the capability to achieve the enterprise objectives. And there will be operational performers serving certain roles that perform those operational activities. So that's what we call the operational layer. And down the next layer down, we call the implementation layer. And this is dealing with resources such as these personnel, and those resources perform functions, and those functions implement operational activities. And the bottom layer is the project we put in place to implement those resources that get delivered at these project milestones. So these are the basic 4 layers that's underneath the hood when you open up a modeling tool and start modeling using the UAF. So here's a high-level view of the meta model. Call this the conceptual schema. These are a couple dozen key concepts. This is just about 10% of all the concepts within the full-blown domain meta model. But these are the main things that you might deal with when you're actually using the architecture. And I will do modeling concepts. And the colors represent the colors of the rows. Green ones are the strategic domain. The blue ones are the operational domain. In the lower left, the pink one, services domain. The orange is the resources domain. The actual resources is the instantiation of the resources defined in the resource performer domain. In the upper right corner, you can also see requirements can be mapped to these elements, standards can be applied to any of the, and measurements can be applied to any of these things. And the pink in the upper right is the project. So the standard, the grid consists of these various domains. So these domains correspond to if you're familiar with DoDAF, these correspond to the viewpoints that are in DoDAF. So in DoDAF, they had an operational viewpoint. They had the project viewpoint. They had standard viewpoint. But some new domains that show up in UAF is like security. Security views came in. The strategic domain, some of those views came from the UK's MODAF and NATO framework. And DoDAF had some of those things called the capability viewpoint. So the capability viewpoint got combined with the strategic viewpoint from MODAF. So here's the UAF grid that's populating all the cells in the grid with the view specifications. So in here you can see there's 71 different views that are available in the UAF framework. So there in the appendix B of the specification is a mapping between UAF and the other frameworks. So if you do generate the UAF views, you automatically get the DoDAF views or MODAF views or NATO framework views. So these views is what you use when you're doing portfolio management, because you want to look at the various system architecture views to see what all the systems in my portfolio, but I'm also might have some business elements. So I have business architecture views. I could have program architecture views. I could have mission architecture views. So all these various views are used by the portfolio management process to figure out what does my current portfolio look like, and what are some alternative ways I can change my elements in the portfolio to the outcomes. We have desired outcomes. Those are basically the evaluation criteria we use for examining alternative futures. So that's why it's very important in your enterprise model to understand the drivers and understand the outcomes very well, because the drivers and outcomes are basically used during the evaluation process when you're trying to make portfolio decisions for getting to some desirable future. Now I'm going to walk through the grid row by row and column by column. So each of the rows represents stakeholder domains, and each of the columns represent different architecture model kinds. So I'm going to pause here and see if there's any questions. I'll go look at the chat window, see if there's any questions. So Alex, Alex sent me a note saying that there's a problem with the audio.
Yeah, it seems like there's some problems with the audio. Would you like me to share the charts?
No, I think we'll keep with the chart, because how does it sound now?
Sounds good now. But you do have a question from James Baker. What will be the impact on UAF from the SysML v2 implementation?
I'm going to talk about the evolution of UAF in about 10 minutes, but I'll say right up front, our plan will be version 2 of UAF will incorporate version 2 of SysML. We're currently working with the SysML v2 team to make sure that the changes they're making will not break anything too badly, because we're going to have to accommodate some of those new features, because they're also removing some of the features that we might find useful. So we're talking to them right, maybe putting those back useful, but we find more useful at the enterprise level. So we will keep monitoring that, and as they come out, we'll try to not the same year, but maybe the following year, because SysML needs to be implemented in the modeling tools, and then we'll take it from there. Any other questions, Alex?
No, that was all.
So
thank you.
We'll move on. We're going to now walk through the grid. So the top row in the framework is called metadata. So this row is really not the kind of views that you would show to architects or to managers. This is really for the modelers. So these are special views that give the modeler insight into the architecture as it gets fleshed out in the modeling tool. So in here is where you structure your containers, your packages, your package structures. This is where you do your framework tailoring. This is where you would define your dictionary. Expanding this beyond metadata, we're going to be changing the name of this row in next version to architectural management, because there's some additional views that you need for managing the architecture that aren't necessarily dealing with metadata. So think of this as the model managers that need these views just for modeling the MBSE project. The strategic view domain, think back in MODAF, that was called the strategic viewpoint, and DoDAF, that was called the capability viewpoint. And the reason is because it's focused on the capabilities and how those capabilities will evolve over time. So one of the key outputs of these is what you see over here in the roadmap column. There's two roadmap views of capabilities: strategic deployment and strategic phasing. And I'll show you examples of those later. But the main concerns here is managing the capabilities as they get deployed by the enterprise. So remember, you're focused on enterprise outcomes. So those outcomes need to be directly correlated with the capabilities that help achieve those outcomes. So the drivers and outcomes at the top level are really tied into this capability evolution. Here are the concepts, the four main concepts that are involved within there. I already mentioned capabilities, but you start off you start off with the enterprise goal. Alex said he can hear my ping. I'm going to turn off the ping on my phone. So if you remember, you start off with the drivers and outcomes. Given the outcomes you would like to achieve for the enterprise, then you establish some goals that the enterprise will achieve incrementally towards those outcomes. And then you map those enterprise goals to particular enterprise phases. So these phases they could be 5-year increments or 1-year increments, or maybe quarterly increments. So in the enterprise architecture, you typically show an enterprise roadmap that's showing things as the enterprise changes over time. Sometimes those phases are called epochs. Sometimes they're called blocks. But within the modeling tool, they're called enterprise phases. So you have your 10 or 20 goals the enterprise is trying to achieve, mapping to the various phases of the enterprise. And then you also have a separate vision for that mapping to each of the phases. And those phases are designed to exhibit the particular capabilities that you're trying to achieve according to the capability roadmap. Okay, so you can see how you can see these are the four main concepts in the ontology of the enterprise. And later on, I'll show you how these capabilities map down into the operational and resource domains. Next layer down, we call the operational domain. This is focused on operational behavior and structure. And by structure, we mean operational performers. And you'll see that in the next slide. That's one of the key concepts, typically called operational nodes. But in UAF, we call those operational performers, so for operational nodes. So in the operational domain, you are trying to be implementation agnostic. You want to be independent of particular solutions because the solutions come later. You're trying to figure out how will the enterprise operate in order to achieve those outcomes given those capabilities. Sometimes we call this the logical architecture. So here are the four main components of an operational architecture. You have the operational agents, and one kind of agent is an operational performer and an operational architecture. Okay, so those are the two kinds of operational agents. There's also a thing called a known resource. So for example, when if your operation depends upon GPS, you can think of the GPS as the known resource. It is a resource there. There could be a building that you know you're going to do manufacturing in, so that's a known resource. So you could say that there's known resources that are acting as operational agents, even though they are a resource. So we make a distinction between a resource, which is some sort of asset that can do something for you. So the resources are used by the operational agents to be able to perform operational activities. Those operational activities map to those capabilities that you're trying to deliver. The operational agents will have ports through which they interact with other operational agents through an operational interface. Okay, so those are the main concepts in the ontology, or the high-level concepts within the domain metamodel. So notice here, let me point out one more thing here. You also have agents can talk to each other through what they call operational exchanges. In DoDAF, those were called need lines. So if you're familiar with DoDAF need lines and operational nodes, think of the operational exchanges is what the UAF calls those need lines, and operation agents and operational performers is what they call the operational nodes. Next layer down is services. Now be careful, this is not technical services like web services, software services. This is meant to be enterprise services, or some people might call them business services. And this is purposely put right below the operational domain and above the resources domain, because the services can act as a buffer between the operations and the resources. And this is one of the basic principles of service-oriented architecture, that services will allow you to decouple changes in the operational domain from the resources. So you can, without changing any of the systems or software that you use, you can change the services that present the functionality of those resources to the operators. Likewise, you can change your operational business practices, and they interact with the services in the same way according to the service specification. And the service gives access to the resource functionality. So services in this sense is implementing the basic SOA principle of separation of concerns, separate the operational domain from the resource domain in a SOA sense. So it's focused on the services that will help achieve and exhibit the capabilities that the enterprise will try to deliver in performing those operational activities. So here are the three main concepts. You have the specification of the service. Each service has a port, and the service interface defines that port. So the service interface will be normally implemented by a resource interface from one of the resource performers. But normally when you engage with a service, you're treating it like a black box, and you deal with it at the service port. So you often don't even know how the service is implementing the service functionality. However, if you're doing a service architecture, you usually need to know what's behind that service interface, and that's where you might be building a system architecture underneath the service architecture for delivering those service specification functionality. So the service is being consumed by the operation activity. Remember, the operation agent performs that activity. So the operation agent is basically using that service through the operation activity. So the activity and the service both map to the capability that's being delivered according to the roadmap. So next layer down is personnel. So this domain did not exist in DoDAF except for one view called the operational, or the org diagram. You might think of that organizational responsibility diagram, the OV4. But this brought in a number of other human factors views from the Canadian framework and from the NATO framework. So this is dealing with the people side of things. Remember, we said enterprise is very much about people. So DoDAF in the past has focused more on the system side, the hardware and software sort of thing, the resources. So we're trying to flesh this out so personnel get the at least equal treatment compared to the technical resources that we traditionally deal with in system engineering. So the 5 main elements, actually 4, the responsibility, person, organization, and post. And those are 4 kinds of organizational resources. So notice organizational resource is a kind of resource performer within the ontology. So those resources can exchange things with each other, and even the organizational resources can have a resource port defined by a resource interface. So this is how organizations can interact with each other. So it could be the individual persons, it could be the post, or think of that as the particular job position, or it could be the responsibilities assigned to that job position, or it could be the organizational construct for organizing the roles and responsibilities. Okay, so those are the main elements from the ontology that show up in the organizational domain or the personnel domain. So the next level down is the resource domain. This is where most system engineers do their work, because this is focused on the various resources, whether the system of systems, software, buildings, platforms. So one of the new terms that you may not be familiar with is what we call capability configuration. So that's really a collection of resources that together deliver a capability that's been defined in the domain. So the capability configuration, some people call those capability packages because they're a package of resources that work together. And these resources could be belonging to more than one configuration. It's the capability configuration that will show up on your capability roadmap. So these resources, if it's specified further detail using a software language like UML, if it's a system, you might use a language like SysML for modeling the system. If it's something like business elements, you might use some sort of business modeling language. Or there's other languages like AADL, architecture analysis design language. So there's a number of different modeling languages that you can use for modeling resources. So this is focused on the solution side of things. Whereas remember the operational domain, I said that's the logical. So think of this, some people you might think of this as physical, but not everything in the resource, not all resources are physical. So sometimes you'll hear people talk about the logical architecture and the physical architecture, or you can think of it as the solution architecture, which also includes non-physical elements, such as roles and job positions and responsibilities. Those are non-physical. So here are the basic elements in the meta model for the resources domain. At the top level, you have types of resource performers. You have a resource architecture. So notice one kind of resource architecture is a system. Another kind is that capability configuration I told you about. Remember, that's your collection of other resources that directly ties to one of the capabilities that's in the capability roadmap. There's 3 kinds of physical resources. Resource artifact, that you might call that hardware, although it's not always hardware. It's not hardware in the normal sense that we talk about hardware. That could be a resource artifact, and let's say it's a transportation domain. It could be the road and bridges. It could be the materials that the piece parts that hardware is built upon. One of the resources is software, and also natural resources like energy, light, fuel. Okay, so those are the 3 kinds of physical resources. So any of the resources performers can perform a function. So the function is what's implementing that operational activity. So those resources are the things the operational agents are using to do their operational work and to perform to achieve their operational goals, which map back up to the enterprise goals. So next layer down is the security domain. So these security views came from the Canadian framework. So this is focused on cybersecurity, but there's no reason why you can't expand that to be security in a more general sense. So we tend to, in fact, we've expanded this to be more than just security. We're also using it for risk mitigation. So any kind of risk, not just risk to your cyber assets. So this security domain is getting a major improvement in the next version. So we're trying to expand this to make risk more than just an IT risk. The projects domain in DoDAF, they have the PV1 and PV2. And so we've expanded this to also include project processes, because you may want to model the project activities and their particular sequencing, sort of like you think of like a project schedule. So you can actually model your project processes in terms of project timelines, and that's also where you model your various projects that make up your project portfolio. So the two main things from the project are the project itself, the actual project, and the actual project milestones. So the project milestones are the things that are delivering those resources that you saw in the resource domain. You can also see security controls that are mitigating risk. So you could just generalize that security control to just say risk mitigation that mitigates the risk. It's just currently this is defined for cyber systems. So it's focused on cybersecurity controls, but there's no reason why you can't easily extend that to risk in the general sense. So the standards domain, as I showed here, you can see in the upper right corner, standards and requirements can both be linked to any of the elements. So you could standardize resources, you can standardize operations, you can standardize organizations, and you can also apply requirements to any of those. But there is a special domain called standards domain. There's just 4 views. There's the standards taxonomy structure, standard roadmap showing how the standards change over time, and standard traceability, which is mapping standards to the things that it applies to. The requirements came in from SysML. DoDAF didn't have any way directly to model the requirements. So this helps you have a better tie between the architecture and the requirements. So the requirements standards can be linked to anything else. And also measurements. Measurements have their own column, which I'll get to later. Measurements, you want to be able to measure any of these elements. The actual resources domain is special in the sense that this is where you connect your architecture to things in the real world. So when we say actual, you can think of that as real world objects. So this is where you tie in your architecture, which is abstract, to concrete things in the real world. And that's when you tie it to your things. When you're doing your modeling simulation, you can tie your analysis, because when you do analysis, you have to model real world things. So the actual resource domain is for tying into the analytics and tying into all your other model-based engineering things like electronics, hardware, software, manufacturing, test, all these other real world things that are going on. So the actual resource elements are classified by the resource performer specification that are in the architecture model. So this is where you have UAF basically gives you an ability to do descriptive models, whereas your modeling and simulation tools will be your analytic models. So the actual resources where you connect your analytic models and tools to the descriptive views of the architecture. The dictionary is basically a definition of all the elements in the entire architecture. Summary and overview, DoDAF, this is called an AV1. It's basically an executive level summary of what the architecture is about, what we're trying to achieve, and what are some of the high level decisions that relate to the enterprise evolution, or enterprise transformation. So now we're going to go through each of the columns. we call these the model kinds because they're different kinds of models. A taxonomic view is showing the generalization, specialization you might be familiar with in SysML. This is where you define your block definition diagrams, and you'd have in the architecture. So this example is the kinds of services. So this is a services taxonomy. So you can see how, in this case, we show these are the services here, and these are the operation activities that are supported by those services. So within the taxonomy column, you see all these view specifications in that column for each of the domains in the rows. So you'll have a particular taxonomy view for each of the rows in the framework. So here's another kind of taxonomy. This is in the strategic domain, and this is a taxonomy of capabilities. So if you're familiar with SysML, you ought to recognize this notation. So you see the white triangle. That white triangle represents that's a specialization type of relationship. So in other words, the maritime search and rescue is a special kind of search and rescue. So land search and rescue is another kind of search and rescue. So think of search and rescue as the more general case, and then you have two special cases down here. So we call this the generalization specialization relationship within the framework, and that comes from UML directly. Here's a third kind of taxonomy. These are the operational performers. These are the kind of performers. It could be a person, it could be a group, it could be an idea, it could be the product itself could be an operational performer, an operational agent. So you can see the various kinds of things that are considered to be things that you're performing the operational activities. Next column over is structure. Now this again, you can see the SysML terminal, the SysML notation. See the black top? That represents a composition relationship, or sometimes known as part whole. So this is modeling a home appliance enterprise. So they have let's say this is a factory building home appliances. So they need a capability for developing the appliances. They also need a capability for producing those appliances. And you can see there's 4 kinds of appliances that this factory can produce: washers, fridges, microwaves, and coffee machines. So also part of development is quality control, research and development, and then you also have these other 4 kinds of capabilities at the top: logistics, finance, legal, and marketing. Okay, so that's an example of a structure diagram and the capability in the strategic domain, because the strategic domain deals with capabilities. Going down a few rows to the resource domain, here is a resource structure. You might recognize this as like a schematic block diagram of a system. Think of these as system elements. So this is an example of an internal block diagram if you're using SysML. Each of these components has interfaces between them. So you can see how these components are connected. You can also see how they connect to the outside world. You can see the ports going around the border. Those are your external interfaces. Going over one column, we need to know how those things are connected in terms of what's going to flow between those elements, in terms of what kind of information. So here we see in this notice some of the diagrams are not graphical in sense of boxes and line, but they're tabular. So here's an example of a table that's representing connectivity. Here you can see this represents the operational exchange items. In other words, the things that get exchanged between the sending performer and the receiving performer. And these are the activities performed by the sending performer and the activities performed by the receiving. So we call those the producing and consuming activities. So from familiar with DoDAF, this was an OV3, like an information exchange matrix. However, in UAF, it's not just information that flows. It could be any kind of operational element. It could be the products themselves. It could be the people. It could be organizations that flow. Going down a few rows to the resource domain, this is a connectivity between the elements of my resource. So remember on the structure view, I showed the connections in terms of the interfaces, how they interact. But the connectivity is show you what flows across those connections. So these are the operational elements that flow across those interfaces that we saw in the structure diagram. Going over one column to the processes, this is an example of a SysML activity diagram. So the columns here represent the operational performers that you had defined back in the operational taxonomy. And these are the operation activities that were defined in the activity diagram. And these are the actions performed by each of the performers and the interactions between them. So notice the interactions that you see on this diagram. These came from the previous, the interaction you define on the connectivity diagram will also show up in the process diagram. Here's an alternative way of modeling process. This is using not SysML, but this is using the business process modeling notation. So it all depends on the modeling tool as to which modeling notations are available within that tool. But you can create these UAF views without using SysML or BPMN or anything else. You can have your own custom modeling language if you like. So the UAF framework allows you to create your own modeling profile essentially. It just turned out the UAF profile is designed to work with SysML, but you could create your own UAF profile for whatever language is your favorite. So these three columns we're going through: the process, states, and interaction scenarios. Those are the three behavior kinds of models. Process, state transition is another kind of behavior. And this is an example using the SysML state diagram. The interaction scenario, this is using this one example is a sequence diagram from SysML. Again, the lifelines represent the operational performers, but you're not seeing here the operational actions. You're just showing the interconnection between the performers, between the lifelines. So it's just a different way of looking at the behavior of my operations. Going over one column, we have various information views. This is where you do your information modeling, data modeling, to represent the model, the information that flows across these connections. Here's an example of an operational information model. Shows you the different kind of information elements and how they relate to each other. Going over one column, we can see the parameters. So these are the properties. Remember I told you that measurements can be applied to any element in the architecture. So these are defining those measurements in terms of the parameters as they apply to all the things elsewhere in the architecture. So here's an example of a parameter view. On the left, you see the green capabilities. Here are the two capabilities. Here's the actual organization that will be impacted by that capability. And here are two specific field of capabilities with particular measures. So we define two success factors here: 95% chance of rescue success and 95% chance of localizing, to finding the location of the person in distress. So this is an example of what a capability parameters view will look like. Going over one column, this is the constraints that apply to your elements in the architecture. This example is constraints on the personnel. So this will be in the personnel domain. So this is where you apply the parametric diagram from SysML, so you can start defining the mathematics, and this is where you start tying things into the analytic parameters that tie into your analysis tools. It doesn't have to be a parametric block. It could just be a tabular form. In this case, these are the textual rules that apply to the different operational nodes. And that column over is the roadmap, because you need to know how things change over time. This example is the project roadmap. And along the project timeline, you can see the various milestones that project is planned to achieve. Traceability is typically traceability between the different domains. So this one maps from the capabilities in the strategic domain down to the activities in the operational domain. Another way of looking at the traceability is through these relation maps. On the left, you have a capability that maps to these activities here. So here's our capability. Remember, we saw development capability on the previous diagram of the appliance manufacturing enterprise. These are the operational activities that are mapping to this development capability. Take the developed product capability, and these are the activities that are needed to develop the product. And these are the activities needed to manufacture the product. And these are the system functions needed to perform quality control checks. So you can see how this view is a multi-hop view that it's typically hard to show in a matrix like we saw before. So most trace matrices look like this, where it's just going on one level, but sometimes it's very interesting to see how things will flow down from one level to another. So I went through all the rows and all the rows and all the columns. So this is the framework grid that UAF provides, and it's just a way to organize the 71 different views that are available in the framework. So it's not exactly two-dimensional. We're just using that as a convenient way to organize the views. And in reality, personnel and resources are really at the same level. So you can think of personnel as human resources, and the other resources are more non-personnel, like technical resources. The actual resources are implementing things in the real world, implementing the personnel and the resources. The security will actually cut across the operational and the personnel resources. Services tend to cut across, parameters cut across. So we have a number of the columns that will cut across. Even though services is shown as a row, services really cuts across all the rows. And projects are the things that are delivering those resources. So usually the model itself is not visible to most people, because what you look at are the architecture views. So one way to think about this, that is, if we put the model inside of a cube, each face of the cube can represent a different modeling domain. So in this case, the front face of the cube represents the operational domain, and I have operational views. The top of this cube represents the strategic domain. This is where I start seeing the capabilities and the enterprise outcomes I'm trying to achieve. The right side of the cube represents the resources domain. So if you change something in any of these views, you can have a ripple effect. As you can see the blue line, you add a capability in the strategic taxonomy, and that could flow down through traceability view into my operational process, which flows down to my resource functionality and flows down to a resource structure element. So I may need to add another interface in my structure view. So each of these views, you can think of it as a window into information inside the cube. So you can also think of a view as a projection of the model. The models are inside, usually hidden from you, and usually what you see is just one particular aspect of that model, or one particular domain, or one particular set of concerns. So remember we showed you these top level building blocks. Capabilities is really about how the enterprise delivers capabilities to achieve certain outcomes. The operational domain is performing operational performers and agents performing activities that are implemented by functions, performed by resources. Resources are usually developed by projects. So the UAF profile and the UAF framework and the meta model is available in many different tools. Some of them, like Tom Sawyer software, doesn't do the modeling directly, but it provides a presentation layers on top of the other modeling tools. So you'll have your common tools like Sparks Enterprise Architect, PTG Modeler, Hopex by Mega, Magic Draw and Cameo, and Rhapsody by IBM, and also System Architect. So those are some of the most common tools that people will use. So what organizations are using them? This chart is actually 2 or 3 years old, so there's a number of others not shown here, but usually the major contractors. And notice it's not just the government agencies. It's not just defense and aerospace. Notice Volvo Construction Equipment, Norwegian Air Traffic Control, Saab does airplanes and automotive, Airbus helicopters. Okay, so it's no longer just defense and aerospace. So somebody asked me before about version 2. Version 2 will be whenever SysML version 2 comes out, but until then, we're working on version 1.2, and the main improvements, which you'll see on the next chart, is to improve the sample model and provide the user guide, which I'll talk to next, and provide major enhancements in the strategic domain, services, and security. And when SysML version 2 comes out in a year or two, we will have a version 2 of UAF that integrates with that. So we walked through part of the modeling landscape. We focused on frameworks and modeling profiles, because that's part of the UAF specification. And now we're going to talk more about the modeling workflow. So why not just use SysML? Everything I showed you, you can model in SysML, but it would require some work. So you would probably have to build your own modeling profile, your own stereotypes, your own extensions. Yes, you can do that. A lot of people do that. The problem with that is you've extended it differently than other projects and programs within your enterprise. And what about your partner organizations? Everybody extending it differently, therefore there's no standard. With the UAF profile, it is a standard for modeling the enterprise. So you have various enterprises that need to do things jointly, then it provides a standard way of integrating the various organizational architectures, the various mission architectures, capability architectures, command services, agencies, and so on. It also provides many other standardized views that cover various other aspects of the architecture. And we've seen examples of all these. Okay, so I'm going to stop here and see if there's any questions. I do see a question here about.
Yes, James. So there was a few questions. To start, from Stephen Cornford, is there a mapping of stakeholder customers to the views. James Baker mentioned that Section 8 of the UAF specification does include a mapping of the views to stakeholders. Could you elaborate or clarify on that as well?
And actually, I didn't cover that, but if you look in these, like this one here, so for each of the views, there is stakeholders identified. So here are the stakeholders for the parameters views. If I go back, so here's the information. You can see the stakeholders for the information views. So within the UAF profile, they do for each one of the views. I don't show them here, but so the summary and overview, here you can see the stakeholders. So within the UAF specification, they do provide not only the stakeholders applicable to that view, but also the concerns you typically are trying to characterize with that view. Okay, so is there another question?
Yes, another question from Samantha is, how would you perform functional decomposition of a system of systems? Might I have an operational activity monitor? I can send this in the chat again. That way it would be easier for you to read.
Yeah.
And then how to break down a subfunction monitor control system data that part of the first system will do with data coming from the second. Is that still within UAF?
Absolutely. Everything you just described is in UAF. I just don't have time. That's the half-day class just on how to do the modeling of behavior. So everything you described is absolutely everything you can do, almost everything. Now then, just be careful. Not everything in SysML is available in UAF. Because remember, SysML is a modeling for a system to include design of the system. UAF is specifically for architecture, so there's some design type features that you don't want to put in your architecture model. Okay, but for the most part, everything you described is in UAF. It allows you to do that. Okay, I see the question, is the sample model available to us? Yes, the sample model is if you go to Google and just type in UAF spec, SPEC, it's usually the top thing list, and you can download the entire UAF specification. And one of the 4 documents is the sample model. If you have the UAF plugin for your tool, normally in your installation folder, there is a sample model that's provided by the tool vendor. So was there another question, or is that it?
So there was one question. Have you briefed the senior NASA DT leadership on this, specifically Jill Marlowe and Tony DeVenti?
We did brief to NASA a few months ago, and I don't know who it was, but we need to take that offline. So send me a note. My email address is on the title page. So please send me a note and I can get you in contact with the people that actually went to the NASA headquarters to brief some of this. Because NASA headquarters asked for our company to provide them an overview of what is all this digital engineering stuff. So Alex, could you paste in my email address? Somebody asked if you could put that into the chat.
Yes, and then immediately above that, when is DoD going to mandate this to their suppliers?
This is already mandated in the DISA standards list. So it's all a matter of when your contract is updated. So new contracts will mandate the UAF because it's now in the DISA. But you'd have to talk to your program office to ask them when they're going to do that, because it's basically up to the program office of when they do that. The Pentagon, the Department of Defense doesn't mandate that all suppliers have to do this. That's up to every program office to decide that. Okay, so any other questions? Let me move on. So we only have about
Yes,
half an hour to go.
just the last question. Can you confirm the difference between the connectivity and the traceability columns?
Traceability is between the different domains. So for example, if you want to trace capabilities to operation activities, that's in the traceability column. That's the traceability view. If you want to map resource functions to operation activities, that's a traceability view. The connectivity is how the elements in the architecture, so for example, how does system X talk to system Y? How does organization A talk to organization B? That's connectivity. That's connectivity between the things in the architecture, where traceability is basically at the model level. It's tracing between different kinds of model elements. Okay, so let's move on because we just have about half an hour to go. I want to give you a quick overview of the user guide. So we have, we already showed you the top level 9 steps, but we decomposed the workflow into third level decomposition. So we have about 130 steps in the entire workflow. So the workflow is designed to handle all 71 views within the UAF framework. So the views are organized by this grid, but we're using the domain rows as the basic 8 steps in our workflow. So these are the 71 views mapped into the grid. So UAF has been around for about 3 years, but a lot of people have had trouble using it because there was no user guide that went with it. Because their original focus was getting the tool vendors up to speed. So a lot of the stuff in there was really meant for the tool vendors so they can know what to implement in their plugins. So there's always been talk about doing a user guide, and it wasn't until last year that we kicked it off and we started doing that. So we're about halfway into developing this thing. So if anybody wants to contact me by email, I can send you a draft of what we got. And if you want to become a reviewer, we'd be happy to use you as a guinea pig to before we release it this summer. So we'd love to have some early feedback to people, and there's no reason why you can't start to use it right away, even before it's published. So we want to make this guide map to the international standard way of doing architecture. So we made sure that the guide, the workflow, is compatible with the 42/20 standard on architecture processes. So the focus of the user guide is the elaboration process, because that's the process that generates the architecture views and models and views. Okay, so that's the appropriate process, because our user guide is for UAF, which is a framework for developing models and views. So architectural elaboration does generate these views for the evaluation process and conceptualization, but they can also generate reference models, patterns, templates that can go into your enablement process to be put in the repository. They can also generate management-like views for management review and assessment, and also views of the architecture for decision support. Remember, that's where your portfolio management comes in. Remember, I said one of the main reasons for doing our enterprise architecture is so you can inform the portfolio management process and inform enterprise decision makers. That's basically what the architecture governance process is about, is making major decisions about changing the architecture, whether it's system architecture, software architecture, enterprise architecture, doesn't matter. It's the same governance process. So this elaboration process can generate views for various sorts. And when you start using any kind of framework, you have to know ahead of time who's the intended audience for the views I'm going to create, because creating models is not easy. You want to make sure you're going to create the models that will be most effective and useful for informing people about the thing you're modeling. So we're focused on the information elements of UAF. In other words, the architecture views. In other words, what is produced and why you produce them. This gets back to your question about stakeholders. You know, each view has a particular set of stakeholders and concerns that are involved in that view. We're not defining methods or tools. We're not telling you how to do the modeling, who does it, when they do it, or where they do it. So we're gonna, because that's got all that stuff is gonna be part of your methodology. So our plan is to have this thing produced by this summer. We're about 50% through. We've got steps 1 through 5 done, and we are working on the last 4 steps, 6, 7, 8, and 9. So the basic outline, there's some standard stuff we have to put at the front in terms of front matter and preface. And then we're going to spend about a dozen pages giving some background, giving some overview of UAF. We don't presume the user is very familiar with UAF. And we don't even presume that the user of the guide will be a modeler. It could be an architect. It could be a project manager. It could be somebody who's in procurement who needs to understand, why are we buying these modeling tools that cost a lot of money? Why are we training people a certain way? Okay, so then we're going to give you an overview of the guide in about 8 pages. And each of the 10 major steps will have about 4 to 5 pages each. So the total document, we're shooting for about 80 pages. So we want it to be short and simple and not full of modeling jargon. So we're trying to use plain language wherever we can. And we're going to make this available. We're modeling this workflow, so we can make the model itself available. But OMG requires us to publish a PDF document, so we're going to do that. But we also want to publish an HTML model, which is you can post on your web page, and people can navigate through the model just through their browser. So we're using the stakeholder domains within the grid, basically the rows of the grid, as the basic constructs for the workflow. Now, this is not meant to be, this is not a sequence of action. This is not a process model. We're not modeling process, we're modeling workflow. In other words, these are the logical connections between these domains. So in other words, the operational domain will generate information that feeds into the services domain, which generates information, feeds into the resources, and standards applied generally to resources, and resources mapped to personnel, security, projects. So this is roughly how they logically connect. But if you look at the entire, the model, the workflow model, you'll see there's a lot more connection and feedback that's not just flowing from the top to the bottom. But generally within the UAF grid, they are, you can think of them as levels of abstraction. So strategic is much more abstract than services. Services is much more abstract than resources. Resources is more abstract than projects. And projects is more abstract than actual resources. So in general, these represent the layers of abstraction when you're building an enterprise architecture. So for each of these domains, here I just showed the kind of information that's relevant, the kinds of information you're generating when you're generating architecture views for that particular domain. And we pretty much covered all these kinds of things, but if I had a few hours, I can go through all these things in very much detail. And by the way, if you want me to present the same information to your organization, I'd be happy to. You have my email address in the chat window. It's also on the title page. And or we can go into detail. We have a 2-day class with the Aerospace University where we teach many of these concepts. We also have a 3-day SysML modeling class where we can talk to how you would apply SysML to this. And there's also a 5-day modeling class for UAF. So we do have a class scheduled in late April for the 5-day UAF class if anybody's interested. So let me know, and we can put you in contact with the people, get you in the class. So there's basically 9 steps in the process, and it's meant to be an iterative process, because at the enterprise level, you don't do enterprise architecture once. You typically do enterprise architecture on a recurring basis, whether it's once a year, once every other year. You don't change the enterprise architecture every month. So you might do it twice a year, or you might have major changes once a year and then minor changes every 3 months. But this is designed to be cyclic, just like you typically do, a typical workflow for doing enterprise architecture. So step one is, what are those drivers? Remember I said enterprises, you have to know what the drivers are. What are the challenges? So step one is where you define the drivers and those outcomes. And what are the challenges for the enterprise in delivering those outcomes? Step two is where we go into the strategic domain, define the strategy in terms of enterprise phasing and the capabilities we can map to those phases. Then we get into the logical architecture of operation, the black box architecture services, implementation architecture for solutions and resources, organizational aspects of personnel, the resilience aspects of security and protection. And step 8 is where we finally get to having various views of the entire portfolio of the enterprise. So that's where you manage their portfolio and examine the various trade-offs between the different portfolio options. Step 9 is where you take the real world things and map it to the thing in the portfolio so you can do your analysis. And we have step 0 at the top, which is just really just planning and preparing for the next cycle of doing these steps 1 through 9. So this is zooming in a little bit on the steps 3, 4, 5. So you can see there is quite a bit of interaction. So if you see the dark blue line here, I'm sorry, let me get the, okay. So see this blue line here. Sorry, let me get a different drawing pencil. So this blue line here, this represents the main flow. Remember, this is the workflow. So you can see this main flow, and it kind of zoomed around. But you can also see there's a lot of interactions. So for example, this thing here is interacting with that. Let me see if I get a. So this element here has an interaction with that. This has interaction with something off the page. So there is a lot of feedback, like for example, this right here. This goes off the page, but this one connects to, sorry, I'm trying to get this one here. This one here has a connection to this one over there. This one here connect to something off the page. So we do have a lot of, and this whole thing is modeled. So I can give you the model. We happen to model it in Cameo, but eventually we'll have this modeled in all the popular tools. And we plan to make all those models available. Our hope is that all the tool vendors will create their own model that they can provide with their tool itself. So zooming in on the step 3, so you can see here we have things down to the 3rd level. So at the 2nd level here, this is where you're defining the operational. So this is the step 3.2, where you're defining the operational process flows diagram. So this is one of the UAF views. So these are all the information elements. All these represent the views that are in the UAF profile. So we also indicate which DoDAF view this corresponds to. So if you're not familiar with UAF lingo, OPCN means operational connectivity, but in DoDAF speak, that's an OV2. Operational conceptual data model, that's a Div1. Operational connectivity table, OPCN, that's an OV3. So of course, we want to probably be able to switch between the NATO designators and the MODAF designators, but for now we're putting in the DoDAF designators. So notice we go down to the 3rd level corresponds to the lowest level views within UAF. So there's one workflow step per view. Okay, remember I told you there's 71 UAF views, but there's more than one third level steps. The reason is because some of these views get repeated. Let's go down to the next one. Just zooming down a little bit. Here we have down the bottom, we have just further down the page. These particular views all have to do with measurements. So notice there are 3 steps. Measures of performance. This is by type and category. So in other words, these are typical measurements, and these are actual measurements. So notice we're reusing the measurements show up twice on 2 different versions of the OV2. There's typical measurements and actual measurement, and you could either have one single OV2 or you can have separate ones, one showing typical and one showing actual. And then you build the parametric models. This is where you use the SysML parametric block diagram, and you build your operational parametrics view, which all the parametrics maps into your OV2. So notice this OV2 is used 3 times here, but you're applying the measurements and you're applying the parametrics within the OV2 diagram. So let's go over to the step 5. This is the resource architecture. You think of this as the solution architecture or system architecture, if you will, if your resources are only systems. Again, we have these down in the corner here. Here we have three measures of performance, but this is at the resource level. On the previous slide, you saw measures of performance of operational performers, not resource performers. So this is zooming in a little bit, so you can notice some of the red lines represent connections between the major steps. Now these third level views are basically have information that can flow up into this up here. So remember, this is not a process flow diagram. So think of these lines between the views as influence relationships or dependencies. In other words, this resources process flow depend upon all this information down here. It doesn't mean you have to do these views, but it depends upon information like that. Remember, we're taking an information focus. Okay, so zooming in on that, you can see what those steps are all about. Again, this is your typical measures and your actual measures. So again, this is not a process flow diagram, even though it looks like it, it's not. So you need to map these information elements to your own process. Everybody has their own system engineering process. So you could do, since we have this workflow model, you can map this to a model of your process. So how would you use this guide? Well, if you have these, remember the different tiers of enterprise, you can have the 2 tiers. Tier 2 and Tier 3 have an agreement on how they're going to divide up the work for building enterprise architectures and how they overlap. You can have the prime contractor dealing with their suppliers, and they could use it as the basis for agreeing to how they're going to divide up the work, or how they're going to divide up the views. If you're going to build an organizational level methodology, you can use this as the basis for building your methodology, which is process methods and tools. We hope all the tool vendors will install this as a process guide inside the tool. So we're already in the middle of phase 2. We've got about half of the workflow modeled, and actually we have all the workflow modeled, but we're now writing the 4 or 5 pages per chapter for each of the major steps. And our plan is to be done by May or June. And if you want to be a reviewer, just send me an email note and we'll be glad to put you in the queue to get a copy of the next draft. So again, it's a very simple, at the top level, it's very simple, and it lines up very well with the domain within the UAF framework. And it also lines up with the way enterprises do their portfolio management and the kind of view they need for informing decision makers in the enterprise. So I'm going to zoom in a little bit closer on the operational architecture. Here's all the steps of step 3 down to the 3rd level. You can see the entire workflow diagram on the right side. It's got those 5 major steps, and you can see the blue line, which is the top to bottom, is your major flow. The red lines going across are your cross flows between the major steps, and the black lines are linking the 3rd level up to the 2nd level. So these are the basic elements in the conceptual schema. So in the operational architecture, it's mainly these things. So these are the entities and their relationships that are in the meta model. These are the resources that implement. So notice all these resource things can implement an operational thing. So that's what resources do. Resources implement. So remember, the resource performs a function, and then the function implements an operation activity, and the operational agent is performing that activity. Okay, so all these model components, you might call them, model constructs, are in the meta model, and they're available for creating all the operational views in the operational domain. So this is just the top level view of the main 4 steps and the operational architecture workflow. Here's a zoom in on the step 3.1, capturing operational concepts. Step 3.2, capturing operational activities. Step 3.3, capturing the taxonomy. And step 3.4 is analyzing the structure of the operations. So that's all I plan to cover. I do have another part 4. There's the 4th file in there with all the much more process details, and I won't cover that because of the time, but it's there for download if you want to. And if you want me to come, I can focus on any one of these steps and go into great amount of detail if you need that. So I'm just going to leave it for this. Stop to see what kind of questions we might have.
Yeah, so we have a few questions. First, I'd like to start with Tricia. Do you have a heuristic for when you leave UAF to go to SysML, or for when you can safely start to specialize your model so that it doesn't become non-interoperable with other UAF models? Maybe when there is no new external interfaces?
Yeah, you do have, let me go back to the question about SysML. It would be really nice if I could point you to like a white paper that answers your question, because that's a very important question, and we are thinking about writing that. In fact, in our 2-day class I mentioned called Architecture Frameworks and Modeling, we do spend a bit of time talking about when you do UAF modeling versus SysML modeling, and because they're obviously going to overlap, and where do you draw the line? And the second part of the question has to do with when you make extensions to UAF or SysML, at what point do you run into compatibility problems with other people? Well, immediately. So you just have to be careful. Whenever you do an extension, if somebody else wants to connect to your model, they might see that extension and not know what you're talking about. So that's you don't want to force people to never extend their modeling profile. But you have to do that judiciously, and that's why you need to do active model management, I call it. Here, we always talk about requirements management, but I think model management is just as important as requirements management, but it's not considered to be a kind of a separate discipline yet. But we all know, whoever done complex models, we know we need to do model management. So I'm not sure I answered the question about SysML versus UAF, but that's worth further discussion.
Right. Okay.
Question?
Yes. How does UAF enable requirements traceability into a supply chain?
Good question. I think all of our program offices are struggling with that. In fact, Al Hoheb, who kicked us off today, he's working on helping develop some standard contract language that they can put in the statement of work, and some standard data item description, so you can put that on contracting and get the information you need from the contractor. So that is a big question. In fact, I believe, I could be wrong, but Al, I think isn't one of your SE forum talks talking about that? Or if not, Al can provide something like that to answer more of that question.
Yeah, James, this is Al. We have an upcoming talk on the Model Portfolio Management Guide, which is some of what you mentioned. How do you manage a collection of models? On the System Engineering Forum slate, we don't have the digital acquisition information. However, I am recording that for the Air Force Material Command digital campaign effort, and they're going to be releasing that to the public in the next couple of weeks. So I just finished the recording today, along with the associated charts. There's an Excel spreadsheet, and there's a Seadrill package that will be available for those that know about the Air Force Material Command digital campaign. Over.
Okay, that's good information. So I'm going to go to the bottom of the list. Question: are there examples that demonstrate all the UAF domains and viewpoints? Yes, that search and rescue sample model is part of the UAF spec. And all the tool vendors provide a sample model using their tool for that search and rescue example. And I have various models that we built we can show if you want to see something more specific. A link to the classes we offer. Alex or someone, can you put the link to the Aerospace University? Of course, that's only available to aerospace employees, but if you have my email address, some of those classes are available to non-aerospace employees, and all of them are available to government employees. As far as contractors, there are a few classes that are available that way. Either Alex or somebody, if you can put that link in the chat window, would help.
I'll look for it now.
Why does the process guide steps reference the DoDAF views and not the UAF views? Actually, it references let me show you that. It actually does reference the UAF views. That's what the name and the 4-character designator. See OPCN? That's the operational domain in UAF, and the CN is the connectivity column. So that is the UAF designator, but we put in brackets the DoDAF designator because a lot of people are trying to convert their DoDAF architectures into UAF. So this just helps them in the transition to figure out, okay, I've already got an OV2. Where does that fall? I've already got an OV3. Where does that show up? So that's the main reason we're putting that in there, so people can have an easier time transitioning from DoDAF type models to UAF models. Alec, any other questions? I don't see any right now, but maybe further up there are some questions.
So there was a comment, this guideline seems very view diagram based rather than model based. Are there criteria for model development and maturity step by step beyond indicating which view is relevant?
Good question, Rick. Welcome. Good to see you're here. To answer your question, that's in the methodology that you or someone else will have to write. That's a methodology question. In other words, the criteria for developing models. That's what a modeling methodology is all about. UAF is only the views, but it provides the metamodel constructs so that you can base your methodology using the metamodel and using these views. So the modeling profile is starting to get you there because it's got view specifications for each of the views and all the model components that you need to build that view. But it's up to the tool vendors, because every tool will actually develop the model differently based upon the UAF view specification. Okay, so I'm not sure I answered your question, Rick, but UAF is very much view focused because that's just the nature of architecture frameworks. And the profile is mapping the SysML modeling language into those views where it makes sense. Any other questions, Alex? We got about 6 minutes left. I think Al has some wrap-up messages. Now, just to remind you that my email is on the title page. Feel free to contact me, and we will wrap it up the recording, but then I will stick around for another half hour or so. If you want to, we're going to open up the mics and let people talk, and maybe somebody just wants to make some comments or ask a question in the chat window. Alex, any other questions I should take care of?
I believe that's it. If I didn't address your question, please put it in the chat again and I'll bring it up to James. Or if you stick around at the last Q&A session, go ahead and ask it then as well.
Yeah, there was one question, where can I find the link for the UAF Metamodel? Go to Google, type in UAF SPEC, UAF spec. And it's probably the top thing in the list will be the link to the OMG webpage where you can download the entire Metamodel. In fact, Alex, maybe you could do that right now and go to that page and put the link in the chat window. There you go. See the OMG spec. Just follow that link and you find the 4 documents, the Metamodel, the profile, the traceability and the sample model of search and rescue. Okay, Al, I think you had some closing words for us.
Yes, I do. I've got 2 closing slides, so if we could bring those up, that'd be great. Well, James, thanks so much for being our subject matter expert today, and I really appreciate the audience participation. That really helped bring things alive. So we'll continue the dialogue after this set of slides and concludes our presentation. So today, the PDFs and the associated reference paper are already on the System Engineering Forum sites for download. As I mentioned, the recording is going to be available on our Aerospace YouTube channel. If you've registered for this event, then you'll get an email that explains what the URL is and when it's available. Also, we're going to follow up with a quick survey. I think it's five questions. That'll give us some feedback on what you thought about our initial talk today, but also elicit comments and questions or ideas for future talks. So that's really important to us. I appreciate your feedback. And if you want to register, please register for the rest of the events. You've already been apprised that we close registration 2 days before. However, if you miss an event, there's the other download channels and the YouTube videos you can catch up with after the fact. So let's see, we provided a couple of things in the chat window, Dr. Martin's address and some other references. So I think we're good to go there. We can move on to the next slide. So this concludes the formal presentation. We're going to end the recording at this point, and we're going to enable the mics for the folks online. And that way we can take both chat questions and also Q&A.